Alright, so welcome back again. My name is Jesse, and in this wonderful and exciting tutorial, we're trying to see how to build a very simple app for static code analysis using Streamlit and then the new features of the tab, right? So if I come back to this app, I can just paste in the code here, and then if I click on analyze, it's going to analyze the entire code, and then it's going to give us the result. So static code analysis is the concept of trying to analyze a particular code before runtime, right? Before the code is run, before it is compiled, we're going to analyze the code for bugs, for linting, whether it is following a particular styling convention, for bugs and for vulnerabilities. So let's see what this app does. So if I come down here, you can see the raw metrics. So the lines of code, the logical lines of code, SLOC, the comments, the multi-lines, blank lines, single lines. So these are raw metrics that you are getting from the code. So if I click on the original code, you can see it from here. That was exactly the code we pasted above. You can see that we have these comments here. So 1, 2, 3, 4, 5. Right, so that's why you had the comment as 5, right? So it's able to identify some details about the code, right, before it runs, right? This is not being executed. Very nice. And I can also come back and see how complex my code is and how maintainable my code is. So for the maintainability index, that is how maintainable is this code, right? It's 86. That means that it is easy to maintain. Then how many independent decisions are being made here? How many if conditions? How many for loops? All of these things help us to know cyclomatic complexity. And this is F. That means that it's not that bad, right? Very cool. So that is some basic metrics. If I come down here, I can also check for the house state metrics, which is going to show you the number of operands, operators, together with the estimated difficulty of coding this particular stuff, which is not difficult. 1 is not difficult. You can see the effort it will take. That is the amount of time to take to design this simple code and the expected bugs, right? Very cool. So that is some simple static code analysis we can do with this app. I can come down here and I'll click on the reserved. If I go with the reserved, you can see the reserved keywords plot. So a reserved keyword is, these are words that are reserved in any programming language. That is, they are part of the syntax of the programming language and they are reserved. So those ones you can't use them, right? So the reserved keywords for our code, this is it. We have true, def, else, for. These are Python reserved keywords, mostly the same in most programming languages. Then I can also get the cloud, word cloud, right? Or I call it code cloud, like word cloud for the code. You can see the amount, the frequency of the most used words within our test. So you have sequence appearing more, you have def, you have initial value, you have iterable. So these are the most frequent words within our code. So I can get the word frequency here in this table. I can also get it in the format of a pie chart, right, for the reserved keywords. Very cool. So this is more of an if type of code. A lot of conditions here. Okay, I can move on again to the identifier. So an identifier is anything that is not part of the reserved keywords. So anything that is going to take a namespace, like your variables, your functions, your classes, all of these things are called identifiers, right? So we have all of these individual identifiers, as you can see from here, right? Very cool. And then I can go back to the AST. So AST is abstract syntax tree. That is going to be, everybody knows what AST is. It allows you to be able to see what is going to be converted to bytecode and then to machine interpretable code and machine code. That's the big understanding. So the function is my function, and this is how it's going to be converted over. That is something very basic you're going to build, right? So let's see the simple workflow for this particular app. So the basic idea behind this app is that we are going to have a session in Streamlit. Everything is being built in Streamlit, and then we are going to paste our code into Streamlit, right? Then when we paste the code behind the scene, we are going to clean and process our code, and then we are going to do static code analysis on it using Radon. Then also going to write some custom functions to be able to get the reserved keywords and identifiers, and then another function to get the AST from it. So this is a basic app workflow, right? Okay, so let's start everything from scratch. I hope the audio is good and I hope the video is also okay. Let me know if you like this approach. So I'll go back again to our workspace. So the code is already here, right? But this is for private. So let's start from, so I'm going to go back again and I'm going to write everything from scratch, right? So go to GitHub and go to create a repository, then start from there. So let's go back. So I'll go back again to our place and go to create a repository. I'm going to create a new repository. Let's call it a static code analysis app, right, something like that. So that is the name. We can make it simple, so SCA app, but yeah, this is better, right? Okay, so that is something very basic that you're trying to build, and now I'm just going to give it an example. So static code analysis app with Streamlit, right? And then Python. This solely for Python. I'm going to make it public. I'm going to initialize it with my readme. So let's initialize with readme. You can also add getignore for virtual environments, but let's go with Python. Right, using a template for Python, and then I can just go straight away with this, right? Create. So this is going to create a repository. So static code analysis. Later on, maybe in the future, we'll just change the name. Then I'll go back here and I'm going to clone it. Go back, then I'll go back to my workspace. So this is my workspace. Here's the old one, right? I'm going to get out from this place, and then we're going to start writing some code. So git clone, paste it here. So go to clone it perfectly there. So if I go back and I check it out, we have it here. Static code analysis. We're going to move into that particular one. As you can see, we have our simple readme. Perfect. So let's create a virtual environment in which we'll be trying to use for our stuff. So pip Python 3 -m. You can also use poetry, or you can use pip env. Then I'm going to call it as env. Then let's call it as e.agbe, right? So let's make it here. I'm going to create a virtual environment called vnv in this particular folder. You can see that it's here, and now I can activate this source, activate my vnv, and activate. Perfect. So if I go back and I check it out into my, if I check this 3 vnv out, let's make it just one level. So level 2, you can see we have all of these things. So activate to activate, pip to install some packages, and the particular Python version. So let's install some packages there, right? So pip install. So we're installing Streamlit, that's our core package. Then also be installing pandas to help us with reading. Let me bring myself down. Right, be installing pandas. Be also installing Altair. So pandas, Altair, Wordcloud, and then we also install Plotly Express, and then Matplotlib. We also install Radon for the static code analysis, and then these are the main one we'll be installing, right? Very nice. So we have Streamlit, the core, pandas, Altair, Wordcloud, Plotly Express, Matplotlib, and then Radon. We'll install them perfectly for us. Now workspace, and then after that you're going to start writing some code. So in case you have any question or contribution, you can put inside the comment section below. Let me know your opinion, right? If the audio is also okay. I don't know whether there is some bugs within it. Perfect. So we are done with it, right? So now come back again. We have, so let's create our first file. Let's go and call it as app.py, right? Then I'm also going to create another file. So touch here, just let's keep it like this. I'm going to open it with Sublime. And also use VS Code in case you want, but I prefer Sublime. Okay, then I'm going to start writing some code. So the basic understanding is that you're going to start writing some very basic code. So let's import our core packages. It's going to be our core packages. So we'll be importing Streamlit. So import Streamlit as st, right? And then that's the basic stuff we'll be importing, right? Then we are also going to create our main function, and I'm just going to specify the name of it. So title is going to be static code analysis app, right? Something very basic. Then from this we have done, we are going to just go straight away and then close it with the if main. Okay, so let's run our app and make sure that everything is working. So I'll go back again and stop the old one. Yeah, and I'll come back here to this where it is, right? So if I check it out, you can see it all. So I can now run it. To run it, I can just run it with this Streamlit run app.py, right? But because we can also do it like this, Python 3-m, right? And this is going to be running with the Streamlit of that current instance, right, of that virtual environment. As you see, static code analysis is there. Perfect. So we are done with the main aspect, or the simple basic aspect of it. So let's move on to some basic stuff of it. So we're using Streamlit tabs, right, for that. So I'll go back again. This is going to be our tabs for layout. So it's going to be, the tab is very simple, it's a very nice feature. So to work, we're just going to go with my tab 1, right? It goes with it. So it's going to have your variables here, and then your st.tabs, right? So this takes a number, right? A list rather. So this, whatever is going to be taken here, is going to be a format of a list. Yeah. So this is going to be the names that are going to be used for the tabs name, right? Very nice. So in that case, let's put our first tab. The first one is going to be our code analysis. The second one is going to be for our keyword reserve keywords. So let's go to reserve. The next one is going to be for our identifiers, and the last one is going to be for the AST, right? AST. Perfect. So if you are having 4, we must unpack here. So tab 1, tab 2, tab 3, and then tab 4, right? Perfect. So if I stop it and I come back here, automatically let's go with always run. You're going to see that we have our tabs here, right? Which is very, very cool and very nice, right? Very cool. Okay, now that is it. So according to our workflow, we need to get a place to put our code in Streamlit. So we can use Streamlit forms to help us with that. So I'll come back to the top of this place, and I'm going to put in our forms right here. So so it's going to be with st.forms. I'm going to give it a key. The key is going to be the name for the form. So let's go just my form. Then I'm going to stop it. Then I'm going to create my test area. So I'll call that one as my raw code, which is going to be st.test area. Then this is going to have a simple word. So enter code here. And then we just need to give a submit button. So submit button. This is going to be st.form underscore submit button. I'm going to pass in the name of the button. So label by default is submit, but let's give it as a label like analyze. Perfect. So if I save it and I come back here, so it has no attribute called forms. It is supposed to be form, right? Just one form. And perfect, we have it here. So we can actually paste our code here, right? Perfect. So we are done with this particular aspect of getting our code to be pasted here. The next one is we need to create some functions to pick whatever code there and then analyze them. So I'll come back to our app, and I'm going to, before the tabs, or you can just do it after the tabs, anyhow you want it to be. We can say that there's, oh yeah, before the tabs or after the tabs, you can say that, okay, if the submit button is clicked, right? If the submit button is clicked, I want you to go with my first tab, so tab 1, and this is going to be my st.start header. Just to give it a name, this is going to be my code analysis, right? So that's going to be for tab 1. Then we have with tab 2, st.start header. Then this is going to be reserved, right? So if I save it and I come down here, now if I enter in the code, so let's say hello Streamlit, I click on analyze, we're going to have it here, right? You have our code, you can click on this, it's changing, right? That is a very nice feature from Streamlit st tabs, right? Very nice work, very cool. Okay, very nice. Now let's pick our raw code and put it here. So I want to show it to the user, so you can just go with st.code coming from Streamlit, and I just pass in my raw code. st.code gives you two features. It retains the original stuff, right, in its original form with a copy to clipboard here. So if I put in a Python code, so let me pick some Python code from here. Here's the code we're using from the implement with Python function. If I click on analyze, it's going to return it like that. This is the magic from Streamlit, right? It's going to give you all the highlighting and everything, and I can copy to clipboard. But we need to hide this one because sometimes the code can be very long. So we're using the expander. It's going to be with st.expander. Go to pass in my expander. So let's go as original code. So original code. Then yeah. So that's the basic understanding. The person click on this one, you're going to have the original code here. So if I click on this, you have this particular expander. I click on this one, you see we have the original code, right? So that it makes it more cleaner. Perfect. So we have been able to get our code. This is what we're using. We're going to get our code from here to here, and then we are trying to process it, right? So we need to work on this and this and this. So let's work on the static code analysis. So there's a very nice package called Radon, which allows us to be able to do some stuff. It comes as a CLI and as a package. So we're using the package aspect of it. If I go back here, I'm going to import the other packages. So import Radon. So Radon has the Radon raw as RR, right? And then going to import Radon. It's not random, it's Radon, but metric as, let's call it as RM, right? So we have one for the metrics, right, and the other one for the raw cyclomatic complexity, right? So RM and then metrics. Okay, so let's see how to use these ones to analyze our code. So I have a whole video on how to use that, so I'll just go back again to this place, right? So this is going to be the original one, and now I want to be able to analyze that one, right? So let's start with it. So I'm just going to go to my raw metrics, then just work on, just go with Radon. Radon gives you several features that you can work on, right? So let's explore that one before we move on. So let's go with st.help, and I'm going to go with my RR or DRR. Let's make it like this, right? R, DRR, RR, right? So let's run it so you can see the result. So let's paste in something here, analyze it. If I come down, I don't know why it's not showing. This is under expander for the code. You can see that we have all of these features, right? So we have tokenize, operator, analyze. What we need is analyze. So with the analyze, we can analyze the code to get the number of comments, the logical lines of code, and the rest. So that is what we'll be using. So I'll go back again, and I'll just take off this. I'll take off this, and now let's go that one. So let's give it a simple name. So let's call it as my basic, right, metrics or basic analysis. These are basic stuff. It's going to be my cyclomatic.analyze. I'm going to pass in my code, right? So the raw code. Then to get the result, I can just go back with this option. So st.right. I'm going to pass in the basic analysis. So if I come down here, let's analyze this. We have it here. We have gotten it here, right? But what I want to do is I want to take this one out from it. So let's take it from here, from the expander. So I'm taking it from the expander outside the expander. So we have the code, and we also have the expander separately. Analyze. We have the code, original code, and we have the expander. So the logical lines of code 1, 2, 3, 4, 5, 6, 7, 8, 9. That is the meaning of this. Then the other 1, 2, all of these things are related. Then we also have the comment. There is no comment. There is multi-lines. There are no blank space. There's no single comment. If I add a comment here to my code, if I come back and let me add a comment. Let's say this is a comment, and analyze it. Because there's only one comment, we are going to have it here, right? Comment 1, right? So it's able to analyze the code without compiling it, right? Very cool. So I've gotten this particular metric, so let's put a name on top of it as metric. So I'm going to call this one as, let's give it a name here. So st.sapeda, let's call it as my raw SCA metric, right? SCA is static code analysis metrics. So yeah, we are done with one part of it, right? So the next thing we need to work on is on the other aspect of it. So there's also checking for the complexity of it, how maintainable our code is, and then house state. So I'll just go back again and I'll work on that one. So to work with the house state, just going to go with this. We have the metrics. Let's also import Radon dot complexity as, let's call it as RC for complexity. So we have the metrics, we have the complexity, and now we are going to work on those ones also. So this is going to be the for the other one. So let's call it as my complexity. So maintainability index. So this is going to be maintainability index. So maintainability index, right? So in that case, is going to be my MI result. So most of the time, better you call it like this. So results, or you can just call it as MI. Yeah, result is going to be my RM, right? So the metrics. Then I'll just have the other option of the MI visit. This from the API, right? So don't worry about it. It's from the API. Okay. And then for the other one, other metrics of the cyclomatic complexity, CC. So cyclomatic complexity. This is the number of independent decisions your code takes. So CC results going to be my RC dot the cyclomatic complexity. So CC visit. I'm passing my raw code. Perfect. Then finally, we will also work on the house state metrics. House state is useful to help us check for the bugs, the efforts, the operands within our code, right? And some etc stuff. So it's going to be my how result. It's going to be my RM. No, that is going to be my RM. It's for my metrics the same. Then H for house state visits. I'm going to pass in my raw code. So the CC, right, is for the cyclomatic complexity. MI is for maintainability index. You can also specify for the multi as true, that it works on more true stuff. Like there's another argument, and don't worry about it. So I've gotten our stuff here. Now let's show the result. So let's use a column for that. So column layout, right? So I'm trying to use tabs and columns. The nice feature about the tabs is that you can even put another tab within a tab, right? Unlike the column that you can put another column within a column, you can put a tab within a tab, right? That is very cool. So let's work on it. So it's going to be my column 1 and then column 2. Going to be st.columns. I'm going to unpack just 2 columns. Then I'm going to say, okay, with column 1, I want to put my metric. Then I'll pass in the label for the metric. So let's give it as maintainability index. So apologies for the name, right? It's too long. Then you just give our value. The value is going to be my MI result. And then we also do the same thing, column 2 dot metric, which is going to be my label, which goes with the cyclomatic complexity, which in this case is going to take a value, right? And to get this one well, right, you have to just do my f string. I'm going to pass it inside this option here. So it's going to be this option. Yeah. So I'll pass in my result, which is going to be CC results. Then let's get the first value. So let's save it and let's see what you've done so far. If I click on analyze, so we have our original code, we have the raw metrics, we have the leading index and the cyclomatic complexity, right? So the reason this one came as this was that the original one is supposed to be like this. If I go back to this and I do st.write cc results, we are going to see how it actually comes by. See, this is how it comes. It comes with this particular function together with the lines of code and all of these things. But we don't want that. We want to get these values, right? That is the basic understanding. That's why we are going with this particular option, right? So if I go with the first 0, first index, now we can get the actual result. Right, we have gotten this, right? So the F means that it's not making a lot of independent decision parts, so it's very easy. And then we have the amount and then the name of the function, right? That was being run, right? 3. Very cool. So that's what I brought here. So let me hide this one. It is the actual stuff there. Okay, so we are done with this. Now let's show the house steel metrics. So I'll just put another expander. So it's st.expander. I'm going to pass in my house steel result. It's going to be not the house steel, but let's give it a name of st.metrics, which is going to just go with my st.write. It's passing the house result. So if I check it back, analyze it, I've gotten this one, which is not informative, but the reason it's not informative is that these ones are they have their names there, but to get their names you just have to get that out, right? So this is the same thing above, but because it's indexed, I can just go with 0 and I'm going to get the one with the actual name. So I'm going to index it out, the first one, analyze it again, and now you're going to get it in a better format. So each one is the number of operands, each two number of operators, right? Operators, operands, total number of operators, total number of operands. That's all the different variables and how it is. We have the vocabulary, the length, you have the calculation length, the volume, difficulty, effort. The effort is how much it's going to take for you to build this code. The time is going to take you for you to design it, and then the bugs, the potential bugs you can find in this code, right? We have seen how to work on the first aspect of the static code analysis. You have explored tabs, you have explored forms, you have explored columns, right? You have explored expander using Streamlit. Very cool. And let's move on to the reserved keyword identifiers. So to work on this, I just go back again. That is the next option. So all of these things is under tabs. So let's hide everything under tabs. Let's move on to the reserved. So to work with the reserved keywords, so there is, let's go back and show you. Let me show you. I'm going to go back again to my notebook outside here. In Python, if you want to get all the keywords, reserved keywords within Python, it's very simple. Just go with import keywords. If I import not this, but import keywords, right? Keyword. With this keyword, I can get all the keyword. If I just do dir of keyword, I can get all the keywords there. So this keyword list is found here. So that is where every word that is reserved in Python syntax is found here. right? So it's going to be this option. So keyword dot key w list. So we have gotten yield, wait, while, true, like, try, return, raise, pass. All of these things are the syntax reserved keywords, right? Perfect. So you have gotten that one. Now, in order for us to be able to fetch those ones from a particular code, we can just create a function that loops through all our code and check and see if these words are there, and then give the word count. So how do we do that? So we have already seen that this is going to give us the keyword list, right? This one gives us a keyword list. Now, to be able to look through it and count from it and get it, we will just have to first strip all the words. So let's say I have a function like, let's see this one here, like this. So I have the same function. Let me change it. Let's say I have this particular function. To be able to get all the reserved keywords, there is if, there is else, there is for. We need to make sure that some rules are being made, right? Some rules are taken. So first of all, we have to strip this entire stuff. The code, this is code, but it's also test, right? Code is still test, and if it is test, it's data. So if it's data, we can manipulate it. So because of that, we can tokenize the entire stuff, right? We are bringing N over here. We can tokenize the entire stuff, take out all of these things as tokens, right? As word tokens. But to be able to get it the right way, we have to make sure that all of these things equal to the bracket, the comma, which are special characters, have been stripped out. So we are going to strip out all the special characters. So the rule is going to be like this. So we're going to strip out special characters, right? With the exception of underscore, right? If underscore is with a word, right? That is the basic understand, because you know this is together, right? This is also together. Otherwise, you will not get the actual identifiers. Perfect. That is the first one. Then we are going to tokenize the entire stuff. After tokenizing them, we are now going to get the word count or frequency. As a basic understand. So these are rules. So strip special characters first, tokenize the entire stuff, and get the word count, right? That is how to get the number of reserved keywords within our test. So let's design that particular function here. Right, so I'm just going to go back again. Let's write the function. So the first one is we must strip special characters. So def strip special characters. Right, you can also use neat test to help you with that, right? If you want, we're going to pass in our document or test. Then there are several ways you can do that. We can use regular expression, which is the simplest way. So let's import regular expression, and then I'm just going to go with this option here. So the simplest way is that I can just go with this, and let's call that, say, my new string, which is going to be, I'm going to create my pattern. So re.sub, I'm going to substitute every place. Is going to find this particular rule, and it's going to go with my regular expression literal, which is going to take in every word within this particular bracket. So to get all to get all special characters, the simplest way is just go with A to Z, right? And capital A to capital Z, and then 0 to 9. This is the syntax. So this is going to strip everything that is not this. So that includes special characters. And then when you get those things, we are going to change them. We are going to replace them with empty space, right? We're going to pass in our docs there. And we're going to return this new string. So this particular function can be used to strip out any stuff. So let's test our function. I'll go back here, test it. So let's say I have my test here, which have this same test we have. Copy this one as my test. So it's going to be my D for the test. And in case I want to strip all the special characters from this particular word, I just go with my strip special characters, and I'm passing my D. So now it has stripped and has given us only the empty spaces, right? That is a basic understanding. So this one has, from this our entire stuff, that's taking out every special characters, right? He's showing us the special characters, right? But we don't want to get the special characters. These are the special characters. We want to get those that are not the special characters. So to do that, just go back again to our function and then change it with this here. So everything that is not this, we are going to use the caret. I don't know how they call it, but the bracket sign. So I'll go back here and I'll put that particular one here, right? This particular one. This is going to give us the opposite of it, right? So let's run it again and let's run our function again. And now see that we have gotten all of these things, but this is not the best. We need to get some space in between here, right? So I'll just go back again and paste in some space here. We need a space. And let's run it again. And now we have gotten the separate ways, right? That is how to strip out all the special characters. So the rule is this one. But have you noticed that it has stripped off the underscore? My reduce is now separated into two. But as you know, my reduce is together, right? Based on the Python coding style, my reduce underscore, my underscore reduce is together as one word. So the other alternative is, instead of going with this, we can just go with this option. Go with the word level option. So the word level is going to be the same thing that we have done, but now it's going to be backslash. Right, instead of this same thing we have done, we're going to be using the backslash option. Let's go back to where we're working on here. So just go back here, just go with my backslash, then word class, right? So everything that is going to be, you have picking the word level option, right? So if I go back here and I run it, the same thing we have done, we just changed the pattern. And now if I go back with this option here, now we have gotten everything, and this particular word is now together. Initial value is also together. This is how we want, right? We have seen how to work with that. So this is now going to be changed from this place. No more using of this, using a different function, the same thing that we had here. Now I'm going to change it from this to the word level. So this is going to go with this option here. So backslash w plus any word, right? That is the basic understanding. So that is what we need. So we use this one to strip our words. That's the first rule. Then we also have to tokenize it. To tokenize is going to be very simple. So we just do that. But let's go on with the word frequency. So to work with the word frequency, just like this. So we're going to create a function. Let's call it as reserved word frequency. That's the name of the function. You can just call it as, say, get reserved word frequency. Yeah. I'm going to pass in our document, our test. Then how do we do that? You first of all have to strip out these things. So that's the first thing. So let's go to cleaned docs. I'm going to strip out with the function that we have above. So pass in here, strip everything out. That's going to clean everything. You need to get it as token in order to work with it. So it's when we get the tokens that we can count through them. So to be able to do that, there's a simple way we can do that using collections. So from collections, import default dictionary, and with default dictionary you can actually look through a stuff, right? So let's say I have a word there. So we already have this word here. So let's go to s. I want to get all the counts from that. I can just go with s.split. It's going to split them as tokens, right? Everything has been splitted. In case I want to get a word count, I can just go with from collections, import default dictionary, or I can also import counter. Any of them can work. If I go with counter and I pass in my s for the word, so we have gotten them, right? The reason it gives us this option is that it's supposed to be in this option here. As a counter goes with this option. We had it as my, I don't know how we called it. How did we call it? I've forgotten how we call it. Just s, yeah, this one. It must be in the format of a list, right? For counter to work, so split. Then we have gotten it, right? So this is one of the simplest ways of getting all of them. So you can use counter with this option here to get everything. You can also use the for dictionary. In that case, it's going to be the same thing. It's going to be say for I in my s dot split. You are splitting everything to get those tokens. Then before we go that, let's create a dictionary. So let's go to my reserved keyword dictionary. This is not the best way of naming it, but let's default this. Then this takes an integer, right? Because we're getting the integers, we're counting them. Then we say for my I in the s dot split. We're going to look through them, right? You're going to see that, okay, if that particular word, so if I is in our keyword list, remember that we had our keyword list, keyword KW list. If it's there, then we want to add it to our reserved keyword. So to add it, just go with this option here. Go to pass in that particular word. So that particular word is going to be used as the key. Then I'm going to add to it. So the class is equal to, you can add one to it. So in case it finds another time, you have to add one to it. If it doesn't find, it's going to skip, right? That's the basic understanding. Then if I go back, so if I go back to this, then now we have gotten the same thing, right? Very cool. So that is one of the ways. So we're using this particular approach to help us. You can also use counter, but this is also one of the ways you can also use it. So let's see how to implement this there. So you have understood it. So it's going to be for I in my clean docs dot split. It's going to get us in a tokenized format. It's going to be tokenized. Tokenized, right? Then from there I can just go straight away with this. So if the I is inside my keyword dot k list, right? If it's there, I want you to add it. So let's get our keyword. So reserve keyword dictionary. So keyword dictionary. Then from here, I'm just going to initialize the default dictionary. So default it integer. The integer is very important, right? So if it's found in there, we are going to add it to it. So reserved keyword, going to pass in that particular word, then I'm going to add one to it if it finds it there, right? So this is going to be for the reserved keyword. We can also do the same thing for, let's say, the observer. So anything that is not part of the reserved keyword is part of the identifier keywords, right? Right, perfect. But you notice that a word like this, like if I go with map is not a reserved keyword, neither is it an identifier. It is in between, right? It is an identifier that is found within the standard library, right? So in this case, is if I go with map in keyword list, it's false. It's not found there, right? It's not found as reserved keyword. So we have to also create another function to get all the inbuilt words. So to that, just go with this option. So import built-ins. Then all the built-ins are found here. So all the words, there is bar zip, there is also map here, right? So we also have to create another dictionary for that. So I'll go back again and work on that one here. So let's go to my identifiers dictionary. And let's go with the built-in. So built-ins dictionary. So we have one for all of these things. Now let's get, so if the word is found within this, fine. But else if I in built-ins, not built-in but built-ins, we have to import built-ins. So I can just go with my list dir built-ins, right? If it's found there, I'm going to do the same thing. So built-ins dictionary, going to pass in the same thing we did above, check and see if it's there. If it's there, you add 1 to it. If it's not, you add 0. Then the next one is going to be identifiers. Any other thing is going to be an identifier. So if it's not a reserved keyword, if it's not a built-in keyword, then it's an identifier. So we're just going to add it straight to this. So I, then we can just give the count of it. So plus is equal to 1. Okay, so we have gotten a simple function. Now let's return the result. So we can just give it as a result as this. Let's give it in the format of a dictionary. So I'm going to create a simple dictionary. If you have any questions or contributions, you can just put in the comment section below. Let's go with our reserved keyword. So reserved, going to be from the reserved keyword dictionary. We have the identifiers, going to be inside the identifier dictionary. Then the last one is going to be my built-ins, which is also going to be inside my built-ins dictionary. Now we can now return the result. Yep, perfect. That is a simple basic function I've created, right? So let's test this function before we move on. I'll go back again here. We need to import some things, otherwise it's going to give us an error. So let's import built-ins and import keywords, which I've already done. Now let's run it. So what let's get reserved keyword. We're going to pass in our initial work, which was the, yeah, I don't know whether it was X, yeah, but I think it was S. So I've gotten the default dictionary for these ones, right? And the reason it's giving us this error is that because of how we splitted them. So you have to make sure that we split them well. So that is why you have to split. After getting the clean document, we need to split them well. And that is where it's giving us this particular option here. Yeah, perfect. So this is the code. I've just put them all inside a file called apputils.py. So this is the one to strip, and then this is the one to get our reserved keywords, right? So we're going to loop through them. If it's found in our keywords, we're going to check. If it's found in our built-in dictionary or built-in words dictionary, it's going to check. And if it's not found in keyword list built-in dictionary, it's going to be sent as an identifier, right? Then now we're going to store them inside a dictionary, and we can now plot them. So I'm going to bring them here, get reserved keyword, and I'll come down here and then call that particular function here. Perfect. So since, let's see whether it's working. Go back again. I think it's working. Let's try it again. Analyze. Everything works. This one also works. Perfect. So I've gotten it well. Now the next thing is we need to plot them and then push the identifiers here. So I'll just go back again and then get the identifiers there. So this is going to be the same thing. So let me copy this for the identifiers. It's going to be 3. And then this is going to give us the same thing, but you know, one of the things I can also do is that instead of getting this one like this, I can now call the function once, right? You can call the function once. Outside of these ones, you can call the function here, right? That's going to be better. So I'll call that function here and use it here, so that we don't repeat ourselves. Then for the identifiers, I can just get it as a dictionary in this option. So identifiers. If I come back to the identifiers, you must get only the identifiers there, right? Perfect. Only the identifiers here. Now we can actually plot this one. So I'm going to get a simple function, and I'll explain it to help us with our plot. Now this is already in the format of a dictionary, so we can actually plot it with pandas. Right, so let's go back again, and then I'll just go back here. I'm going to create a simple function, so let's import pandas std. Then we'll be using pandas to help us with getting that one as in the format of a plot, something that we can plot by and show, right? So I'll create a function called convert to data frame. Right, so this is going to take in my document or my data, then it's going to convert it to a data frame, right? So it's going to be pd.dataframe, pass in my data dot, this is going to be, let's call it my dictionary, where we know that in the future we know that this is a dictionary, my dictionary, right? We'll take in my items. I'm going to convert this entire stuff into a list, and then we can now plot them, right? So we're going to get the columns and then the keys. So let's give the column names of columns, which is going to be this option. Let's give it some simple stuff. So the keyword and then a count. Right, perfect. So this is a simple function to help us with our plotting. Let's create another one to also do the plot, Wordcloud. And we need to use Wordcloud, so you have to import Wordcloud. So from Wordcloud, import Wordcloud. And also need to import matplotlib to help us with that. So import matplotlib.pyplot as plt, and then I'm going to pass in my docs here, and the document that I'm going to be using to do our plot. That's the basic stuff we'll be trying to do. Then I'm going to create my Wordcloud Ravel. It's going to take in my Wordcloud class, then it's going to generate the text, right? Whatever text has been supplied there, then I'm going to plot this to figure. Let's go to plt.figure. This is how to plot with matplotlib for the st plot, st.pyplot. Then plt.imshow, I pass in my Wordcloud. Now specify some other variable, that is the interpolation. Let's set it as bilinear. Then we can now plot the entire stuff. So plt.axis, let's set the axis off, and now let's plot it with Streamlit plot my figure. So this is a simple function to plot it, right? So one to convert it to a data frame, one to do the Wordcloud plot. So let's go back again and then apply it here. So we have our identifiers. We want to get the plot for the result, right? So you just plot it. It's very simple. Since we already have it as a dictionary, you can call it as results to df. So we convert to df. I pass in my result, and I'm picking only one aspect of it, not the entire stuff. I'm picking the result keyword. Right, that is what we got from here. So result is what you are going to be plotting, right? And then when we get it, we are going to plot it with plotly. You can use plotly, you can use alter to plot it. So to plot it alter, there's going to be plot with alter. It's going to be this option. So it's going to be my chart, or you can call it a C. I'm going to go to alter.chart. We need to import alter, then the results as df, not result to df. Let's call it as results as df. That's the first argument. Then mark bar, because we want a bar chart. You need to encode it. When they're encoding, you're going to pass in the S. Where is S? S is going to be, from our data, we have the S as our keywords. And then our Y, that's why we converted into a dictionary. So Y is going to be our count, right? And then color is going to be, we can specify the color to be keywords, right? Yeah, and now we can plot it. So st dot chart, my chart. We need to import our tag to be able to see it working. So I have to go up and I have to import. So import our tag as alt. I think it's a very nice plot. So if I go back and analyze it, hopefully it's going to work. If I go back here, we have our plot, right? Very nice plot. Very cool. The plot is nice. Yeah, we have been able to do some simple plots. Okay, we have been able to do the plot, but we want to make it bigger. So how do we do that? So we can just specify that, okay, I want to use all the column, right? So use all the column width. So use container width. Let's set that one to true. If I go back and I refresh it and I check it that, okay, now everything is being used well, right? So I've gotten the reserved keywords there. We have seen how to do that plot. We can also apply that same thing for the identifiers, right? But let's do the word cloud. So I'll just go back again and let's do it for the word cloud. We already have the plot. So as I said, the new feature of the Streamlit tabs is that you can put a tab under a tab, right? So let's do that one. Let's take off this. So we're going to hide this. We don't need this one. And you want to put a tab under a tab, right? So this is going to be this option here. So it's tab. So T1, T2, T3. Or we can just make it T1, T2, T3. Here, and then just go with my st.tabs. And this is going to be the first one. This is going to be the code cloud, right? The next one is going to be the reports or word frequency. The next one is going to be the pie chart, right? Okay, if I remember. So 1, 2, 3, and then this is going to be the main one. It's going to go up here, and then we just go with this option here. Yeah. So let's do the plot for that. So it's going to be my with T1. We want to put the plot word cloud here. So plot word cloud is going to take the raw code. But it can take the raw code, but if you take the raw code, it cannot be able to plot it well. So what you have to do is that we have to also tokenize the raw code, right? So let's put the raw code there. Let's check it out. If I click on analyze, we have gotten the one we created. We've gotten the word cloud, right? Right. So if putting the word code, you're able to get the raw code for the entire stuff, right? Then for the word frequency, we can also come back again and then put that dictionary there that we converted to a data frame. This is going to be my st.data frame and result as df. Then for the pie chart, you can also use plotly express. So T3. So to do with plotly express, we just have to go with ps.py. So I have to go back again and import it. So import plotly.express as ps. Plotly express is very cool, and I'm going to pass in the things I want to plot. So it takes in the values, which is going to be from our dictionary. We already have our reserved dictionary results, which had this particular, I don't know that you remember. The reserved, which we got from here, which was returning as this reserved, is a dictionary. So that is what we are going to pick from here. Get the values from that as our values, and do the same thing for the names of the pie chart related to the result. Then this was also for the reserved, and this is going to be the dictionary, right? Dot keys. So you see what I wrote there. So keys. And now we can plot it. So to plot, just go with st.plotly chart. This is coming from Streamlit. So let's give it as C. Or it's better you call it figure 2. Figure 2, so we know what it is in the future. If I click on analyze, we have gotten our reserved keywords, we have gotten our identifiers, we have gotten our word cloud, word frequency, and then our pie chart. Hooray! Right, I'm going to do something very nice. So this is only for the raw code itself, right? This particular one is for the reserved. This place is for the reserved. You also have to do the same thing for the identifiers and for the AST. So I'll go back here and then I'll repeat the same thing. So for the identifiers, what we need is we need just the word cloud, and then we need this particular plot, right? So I'll just copy this here. I'll copy this, and then this. That's the only thing we need. That's going to be for the other tab. So let me close this one. This is going to be the identifiers. We have gotten it here. So change this one. See the advantages of using functions. Identifiers. Then we only need one. We don't need this ones. Let's just plot it straight away. So this time we are not plotting the raw code, we are plotting only the identifiers. So we can actually leave it like that. Or we can strip out the other ones that we got the keywords, right, and then plot them out. So let's go back again. So we need to take off this, convert this one into a table, which is here, which is very nice, right? You have gotten it in a different way, and then you have gotten this plot here. Maybe later on in the future we will try and make it more performant. Okay, so we are done with this one. So now let's go on the last one with tab 4. It's going to be for the AST, the abstract syntax tree, right? So how do we do that? So it is very simple to do. There is someone who has already designed the code for us, and his name is let me use the syntax we learned earlier on to do that. Go back again to GitHub, right? And using the GitHub stuff we did, we just go with user. The name was Maligree, right? Maligree. Let's check all of GitHub if there's someone called Maligree. Yeah, and he has a very nice package called Python AST Explorer, right? So in case you have not checked the GitHub docs, you can check the tutorial below. And if I come back here, he has already an app, but we'll not be using this app. We'll just be picking the pass dot app here. This is the very simple stuff to pass AST, right? Using AST itself and then JSON to make it a nice format. That is the code we are borrowing, right? So credits to Maliki. So in case you want, you can just start it here, right? Very nice. So I'll be using this particular code to help us with that. So I've already copied it, so I'll just go back again, and then we're going to import it and use it here. So I'll paste it here. And back. Let's go back again to our GitHub page. I'm going to paste it here, right? So we'll be using it to help us with our stuff. So I'm going to import it at the top. So let's import it. So yes, import parser. If I save it, it's going to compile it here. There's a parser, and then I'll just come down here, and I'm just going to use that parser to help us with our task. So let's give it a name. So st.subheader. So this is going to be AST abstract sentence tree, and then I'll just use that particular result. So AST _ result is going to be my parser dot make AST. I pass in our raw code, yeah, and then you can just go with JSON or Streamlit, and just pass in the AST result. Voila, we are done with the AST. Right? That is the advantage of open source. But credits to him, is very nice. If I come back here, we have gotten our AST. So the AST is already working as expected. Right, very cool. So I've seen how to build this app from scratch using Streamlit. I've seen how to work on the code analysis aspect of it, in which you paste in the code, you get the original code here, right, and then you get the raw static code analysis using Radon, the maintainability index, the CC, the st.metrics. We have also seen how to code from scratch, how to get all the reservoirs within the code, which is this particular one here. I've seen how to use tabs to get the code cloud, and then the word frequency, as well as the pie charts together with the colors. And then we have seen how to also do the same thing for the identifiers and for the AST. So thank you for watching this tutorial. So you have seen how to follow this workflow, right? Post our code into Streamlit, clean it using regular expression, and then some custom functions to get the static code analysis using Radon, reserve keywords using keywords built in, and then our own functions, and EST to help us get the abstract sentence tree. So thank you for watching this tutorial. In case you have any question or contribution, you can put inside the comment section below and let me know your opinion of the audio. See you another time. Stay blessed. So let's recap. So to recap, we have our app here, which is this particular one here, right? So everything is working. These are the imports. We're going to import these particular ones here. We're going to convert. These are the functions to utility functions. I can put these utility functions from here into the app utils, but we can keep it here and it's still going to work. So let's commit our code, right? So I'll just go back again to where we're working. This is where we're working. Let's stop it here, right? Before I commit, I'm going to also apply the same function on this Radon on the app.py. It's giving us an error. So the same thing we did here, we can do this on the app. So the app is not that bad, right? There is made up of functions, and the score is A, so it's easy to maintain. So these are the main functions in our app.py file. We can also do the same thing for the how. So it is not having a lot of bugs. That is the app itself, right? You know what? Let's analyze the app within the app. I'm going to copy the app code itself and analyze the app within the app. This is the app code itself. Yeah, we are going to analyze the app code within itself. Let's do that. So I'm going to analyze the app code within itself. Yeah, this is the actual code for the app itself. And we are using it within the app itself. Let's see how the app is going to rate itself, if it's going to be biased. So the maintainability is 77. CC is the function 15 functions, and then the score is not that bad. There are still methods. Let's see the amount of bugs. Oh boy, the time to take. And then let's see the amount of keywords we have used in our code. Okay, it has a lot of weight. So this code is full of a lot of weight context because we are using context manager, which is good. coding. And then we have, in my opinion anyway, we have the code cloud, a lot of imports, a lot of keywords, the word frequency, the pie chart. As I said, it is fully full of context manager, right? And then let's see the identifiers. Oh boy, these are a lot of words, a lot of variables, a lot of things that are not, these are all clouded now namespace. They are not they are identifiers that we have found. And then let's see the AST. The AST is going to be very, very huge, right? Yeah, so you have seen how to analyze our app with the app. So thank you for watching. See you in the next session. Stay blessed. Bye. Now wait, let's commit it. Let's commit it. So git status. It is there. Now I can just go with git add, git commit /m to add SCA app, then git push. Perfect. So it's available for everybody to see, so you can have access to our app later on. Here, it's already there, right? Perfect. So thank you for watching. See you. Bye.